Hi everyone, welcome to this video. For this video, this is an overview of deep QM. This is the algorithm for the reinforcement learning. This example was made using OpenAI libraries environments and the Atari game. This is the point game. You can find this video game here in the web page of the OpenAI. You can see all the case of the video games for Atari that provides OpenAI. First of all, you must download the game library in your computer. Now, in previous video I made an overview of acute learning. Acute learning is a basic idea of reinforcement learning, most useful as model-free approach to solve problems by interact with the environments to train the agent. Now, this is another approach of reinforcement learning called deep QM. This is the structure, block structure of the deep QM. Deep QM means deep Q learning. This is based of the a deep neural network. So for that reason, we have here the structure as equal as the deep neural network. The deep QM is based on the first phase of convolutional neural network, and the last phase is the full connected neural network. This is called a forward neural network. Basically, we have here as input the image. In this case, is the image of the video game. For instance, we can have here a resolution as 84 by 84, and as a depth we have three layers. This is the RGB color. This image inputs in the first layer, the first convolutional layer. The operation of this layer is the convolutional multiplication. So this technique, mathematical technique, use convolutional properties to make use of the images. So we have this layer have to take a frame of each image and make operations. After that, we can have function activation functions, SRL, or a layers called pooling to reduce the dimension of the images. So to summarize, the convolutional neural network has have to reduce pre-processing the image of the input value. So finally, as our output, we have the image in 2D dimensions. These images can be used as an input of the forward neural network. The forward neural network is the commonly, as you know, this neural network structure. This structure of neural network. We have here a layer called input layers, and hidden layers, and finally the output layer. So the image processed by the convolutional neural network is an input of the full connector layers. So finally, these networks make outputs as a desired value of the neural network. Now, here we have the. So far we saw the architecture of DeepQN. Now this is some equation that have to take into account to make an DeepQ network. So basically the DeepQN is based on the Q learning. So as you remember, the Q learning is based on this equation to update the Q value based of the rewards and the rewards and factors to store the previous information of the environment. So now, taking this into account, we have some updates equation for the DeepQN. So basically because this is a neural network, this have to be trained to update their parameters. This is the weights of the neural networks. So to update these parameters of the neural network, we have these equations. You can see here based on the gradient of the Q value. Now, to get the updated of the parameters of the neural network, we have to make an optimal approach based on the loss function to minimize the error of the outputs of the network. So basically we have here the approach based on the mean square error to minimize the error based of the gradient descent approach or algorithm based or another optimal approach to minimize the error of the loss function. Now this is the formulation of the DeepQN. Now this is the code of this. This is the code of this network. So basically the codes try to make a DeepQN for solve this environment or this problem of atari game. So we can define the DeepQN variable as environment of the points video game. So we define the layers here, and we can define the convolutional neural network and the feed-forward neural network. So defining this DeepQN in our problem, we have here the iteration of the DeepQN based on the buffer multi-buffer experience that have to take into account when we have to design a DeepQN. This is more details in deeper information of DeepQN. So basically the DeepQN have the parameters of the neural network, and in each instance of time, or I mean in each iteration, have to update the parameters and the Q value at the same time. And finally we have the output, that is the motion of this agent for this video game. Okay, this is basically the overview of this algorithm. So take in mind that there are another approach that try to solve the problems of Atari. Another point that have to take into account is that DeepQN is not the most powerful algorithms to solve these Atari video games. There are another improvements of the DeepQN that try to solve more complex dilemmas. So you can find other topics of DeepQN like double DeepQN, that is algorithm based on two DeepQ networks. So because we have in the environments in gym, for instance, that some video games are easy to solve for some algorithms, but when we can try to solve problems like what is it? This is for instance this kind of video game, double dump or whatever. Some are more complex than the others. So basically this is the topic of this video. I thanks watch this video. In the following video I try to make another topics on solution of DeepQN or another approach of reinforcement learning.